This is Math 5, Chapter 1, Whole Numbers. Question number 1. Write the number that is 1 more than 999,999 in numerals and in words. So what we are going to do is take 999,999 and add 1 to it. So we end up with 0,000,000,001, which is 1 million. So this is your answer for part A. For part B, we have 9,999,999, and we're looking for one more, so we just do the same thing. So now we have 1,000,000,000, or 10 million. So our answer is 10 million. So we have 99,999,999, and we're looking for one more again. So as we've already seen, we don't need to just add one. We can just take this, convert this to all zeros, and add 1 in front of it. So we have 1,000,000,000,000,000, or 100 million. And the reason we can convert this all to zeros and add a 1 here is because all these digits are 9. And when you add 1 to 9, as we all know, makes it a 10. And the 1 drops down, adds to another 9, and keeps going until there are no more 9s left. And in that place, we just put a 1. Number 2, part A, write the number in numerals and in words. So for numerals, it's easy. Just copy this down. 7, 4, 2, 9, 1, 6, 8, 5. And don't forget to put comma after every digit starting from the right. So 1, 2, 3, 1, 2, 3, comma, 1, 2, 3, comma. And now time to write in words. So this here is the millions place. So we'll write this as 700, 742 million with a comma here. Then next we're going to do 916, and this is in the thousands. So we're going to add 916. That's thousand place. So next, I'm sorry, 116,000. Leave a comma and then do the ones place, or the tens, and then so it becomes 385. The reason you do not have an and here is because an and signifies a decimal. And in the case of whole numbers, we are not going to have decimals. So we will never have an and in here. So the value of the digit 2 is 2 times 1. So 2 times 1, 4 times 1, 7. Should put the 1 here because each of this is sort of a 1 here. But you need to multiply by the digits here. So we find 2 here, and there's 2 right here. So count the number of zeros: 1, 2, 3, 4, 5, 6. So this is actually times 1 million, which means that the answer here is 2 million. So the value of digit 4, we find the 4 right after it, so 10 million. And so this answer is just 4 times 10 million, which is 40 million. For the digit 7 here, find 7 is right here, and this is 100 million, so we multiply by 100 million. And 7 times 100 million is just 700 million. And so that's the answer. Question number 3, write this in words. So we do the millions first, so 609 million, comma, and then to the thousand, so 3,000. Four, because it's 4 here. And then now we move on to the tenths, hundreds, and ones, so comma, 49. And so that's the answer. So the value of the digit in the 1 millionth place is, so we're going to write out our digits. And we go to the 1 millionth place, which is right here. And so our answer is 9, with all these as zeros. So 9 million. And that's the answer for the digit in the millionth place. So we'll do the same thing for the thousandth place. We'll write this out. Find the thousands right here. All becomes zeros, so it's 4,000. And of all the places with the digit 0. So this question is kind of tricky because we're finding all of the places with the digit 0 and the name. So not their value, but their names. So first thing we want to do is find all the zeros and write the names of each, but as words. So here we have 10 million, so our first is 10 million, so our first answer is 10 million. The next one is at 10,000, so we just write 10,000. The next one is 100, so we just write 100. For this question, 100 million, so that's 100 million, more than 609,304,049 is what? So we just add 100 million. And that's basically just adding a 1 right here. So this becomes 709,304,049. So that's our answer. 10 million less than, which means we'll be subtracting. So 10 million less than this number is, so we just take 10 million here and do simple subtraction. So this will become 59, so 599,304,049. That's our answer. All you're doing is subtracting 10 million because it's 10 million less. Number 4. Question number 4. Write the numbers in numerals. Numerals. This means just write it as a number. So 2 million here, so you know that the highest place you're going to have is the millions. 447,000. So we're gonna have a comma here since this is 2 million and this is in the thousands. So 447, comma 16. Now if you just wrote 16 here, that'd be completely wrong because first of all you don't have 3 digits here, and if you did say you added 0, that would still be wrong because that'd be 160. So what we actually need to do is add a 0 here, implying that we have 0 in the hundreds place, and then you add 16 here. So your answer is 307. So 74 million, but you don't have a thousands place. There's no thousands. So anything in this middle area is just going to be all zeros. And then you have 307, so 307. 82 million, 82. This is exactly the same thing. You're just going to write 82, 0, 0, 0, 0, 8, 2. Since there is no thousands. 406 million. So we're going to have 406, comma, 57,000. So once again, 0, because it's 57, and there's no 100 in front here. 3. So 0, 0, 3. Question number 5. We have 60 million plus 2 million plus 50,000 plus 200 plus 30 plus 9. So what we're going to do is just add it all together. And you might be thinking that this will be very hard and it'll take a really long time. But it actually won't. Because each of these, this digit with a number on it, is at a different place in the number than any other digit. So what that means is basically if you did write it out, so say I did write it out, 60 million, 2,000, 50,000, 239, and I added them all together, you will notice that if I drop these numbers down, I will not have to add any of them because they are in a different place. So 5, so we just drop these numbers down, 2, 3, 9. So our answer is 62050,239. And we don't need to add any of these digits up because they're all at different places. So this is our answer. Now we have 400,600,000, 5,030. And once again, they're all in different digit places. So we don't need to add these all together like this. We don't need to do this here. We can just have, so we have 400 million, and we can see that none of these are in the millions. So we just write 400 here. 600,000. So we're gonna write 60, but we are not gonna put 0 here because we have another number in the thousands. We have 5,000. So we have a 5 here, comma, and then 0, 3, 0. For this question, they give you the answer and they want you to find what to make this. So we have 203,800,062 equals 200 million plus blank. So if we got our number out, so 203 million. Go. So if we write our digit out, 203,800,062, all we need to do is find the digit here, since there is a digit here. It's going to be in the 200 millions, right here. So we go to our place, 200 million, that's a 2 here, cross that out. Skip this, because we don't know what's there yet. It's blank, right, what are you going to put there? So we have 62, and this is in like the 10th place. So we find 62 here, we just cross that out. Because we could just subtract 200 million and 62 here, so that crosses out. So what we're left is with 3,800,000, and that's it. Because we can cross out the 0 here, since zeros in the front can be ignored. So we'll end up with 3,800,000. And that's the answer. For this one, it's exactly the same. Write our number out. 500, subtract the 5 here. 55, subtract 55. 500,000, 500,000, subtract that. And what we're left is with 5 million. So that's our answer. 5 million. So write the numbers in order from greatest to least. So what we want to do first is identify the greatest number. So we're going to look at this digit first, 6666. So they all have 600 million in front of them. So we go to the next digit. There's an 8 here. There's an 8 here, 8, but then there's a 0 here. That's weird. This one's different and it's smaller, which means we can write this in the least position. So greatest, this is greatest to least. So this means greatest to least, as it says. So we're just gonna write this one here. 608,125,823, because this is the smallest number we have right now. So we use that one, and now we can compare this digit, the millions. So 0, 0, 0 are the same. Move on to the thousands. 1, 1, 5. So this one is larger than the rest. So this one's going to be the greatest. So 680,521,823. So we can cross this one out now. And now we move on to the thousands place. 5, 5 are the same. Moving on, 8, 2. Alright, so this one's greater, this one's smaller, which means that this must be 680,125,823. So we cross that one out, which means the last one we have is 680,125,283. So that's our answer. Now the next question is to write greater than, less than, or equal to in each of these weird circle things. So what we want to do is look at both numbers here. We have 80 million and 60,000. Alright, so we have 50,000. 400 million and 900,000. So I already know I don't need to look at, I already know I don't need to add 60,000 here, or I don't need to add 900,000 here and 50,000 here, because this already has 400 million. There's already a 400 million here, and the greatest number that this has is an 80 million. There's no way, if you're only adding 60,000, that you can be greater than 400 million, since 400 million is a very big number, and you're adding another 900,000 on top of that. So our answer here is going to be this is less than this. 620 millions, so 60, I'm sorry, 620, so 620 millions, and 600,000, 600,000. So what we're going to do is we're going to look at the places. So 600,000, what we're going to do is write these. Moving on. So what we're going to do is we're going to write this as the respective number in digits. So 620 million, so 620 millions, and 60 hundred thousands. Now be careful here. 60 hundred thousands. So 6 0 0 0 0 0 0 because there's a 60 here. So think of it as like this is your numbers and this is your hundreds, right? Because you have two zeros. So you're gonna replace this number with 60, so it becomes 60 hundred. But there's three zeros here, so we're gonna add a comma here, which means 60 hundred is the same as 6,000, and 6,000 thousands is just 6 million. So really, this number is 6 million. Nevertheless, it does not matter because 620 million is still larger than 6 million. So that's our answer. Once again, we're going to write this as their respective numerical forms. So 800 millions and 800,000 thousands. So what would this be? Well, first thing we're going to do is just write 800,000. But then this is being in the thousands place, right? So we're just going to make it in the thousands place by adding three zeros after it. So this really becomes 800 million, and this becomes 800 million, but these are the same values, so our answer is equals. Now look at this, we have 60 million minus 10,000, and we have 59 million plus 10 million. So clearly, this should become something like 69 million around, and this would become just about 60 million. And we all know that 69 million is greater than 60 million, so this would be our answer. So this is our challenge. We need to write 4 millions in the form of 100,000s. So what's 4 millions as a numerical value? Just 4, 0, 0, 0, 0, 0. And we're looking for 100,000. But equivalence. So where is 100,000? Well, this is ones, tens, hundreds, thousands, 10,000s, 100,000. So this is 100,000, right? But this is all just zeros. Like, what am I supposed to do with all these? Well, as we saw before with 600,000, it's just 600 and then make it to thousands. So we need to add 6 zeros to something to make it 4 million. And I might be saying, well, can't we just have 4 here, right? 400,000s. But what is 400,000? Well, 400,000 is just 400,000. but that's not equal to 4 million. 4 million has 4 million. So obviously the clear thing to do is just add a 0 to the end of the 4. So it becomes 40,000. In this case, when we write out 40, then we're just going to add 3 zeros, but not really, because you need to take away this 0. You're adding it because this is the numerical value of the 100,000. So really, this is going to be 40, and then we're going to add 5 zeros. So 3, 4, 5. So that's 4 million. And that's equivalent to 4 million here. So we're good. We added a 40. We're good. So we have 4 millions here again, and it looks like we have 4 millions and 4 millions here. So I'm just going to write 4 million here. Right, and then we want 10,000s, thousands, hundreds. So 10,000 just this. 10,000, 1,000, 100. So 10,000, there's 4 zeros here. I see 4 zeros here. 1, 2, 3, 4. Alright, so this is a 400 here. So what we're going to do is just 400. Take this 400 and put it here. So what is that going to do? Well, we have 400 here, and we have 4 zeros here. So 1, 2, 3, 4. We're going to add a comma here and here, and we have 4 million. 4 millions and thousands. Well, there's 3 zeros here, and there's 3 zeros here. So we're going to cut this off, and we're left with 4,000. So what we're going to do? We're going to put the 4,000 into this box, because 4,000 is our answer. How do you double check? Well, we write down 4,000. And all we're going to do is add these 3 zeros that we took off earlier. And that makes 4 million. So we're going to do the same thing with the hundreds. 2 zeros here, 2 zeros here, cut this off, 4 million. Okay. Well, this is not 4 million. This is actually 40,000. So what we're going to do, we're going to write down 40,000 here, but actually we're going to remove the comma now, for now, because we don't know where we need the commas yet. I want to add in these 2 zeros. So 0, 0. There's a comma here, 4 million. Yeah, we have 4 million for all 4 of these. Now for 10 millions. Well, what's 4 10 millions? Well, that's 40 million. Alright? 10,000s, we're going to do exactly the same thing. 4 zeros here, 4 zeros here. Cut that off. Becomes 4,000. Double check. 4,000. Add these 4 zeros. Comma. 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 And it's exactly the same. So 400 millions is exactly what it looks like. 400 million. And we have 100,000s here, which is just 100,000s. There's 5 zeros here, 5 zeros here. Cut this off. Our answer, once again, is 400. Sorry, 4,000. Double check 4,000. Add in 5 zeros. 1, 2, 3, 4, 5. Comma, comma. There's 400 million. 400 millions, and we have thousands here. And we're just gonna write 1,000 here. 1,000. 3 zeros here, 2 zeros here. Cross that off. 400,000. Double check. 400,000. Add these 3 zeros. And as we can see already, that makes 400 million, which is exactly the same. So that's going to be our answer for all of question 8. That's how we're going to do it. Question number 9, write the numbers in numerals, which means convert them to a number. So 430,000 thousands. What was that? Well, we could do 430,000 first. So 430,000, 430,000, and then thousands again. So what are we going to do there? Well, we're going to add 3 zeros because this is 1,000. And once again, this is the number. So we just place 1 with 430,000. Just adds 3 zeros after. 9,860, 10,000. So, well, what is that? Well, 10,000 is 10,000. So I can just write 9,860. Write this down first, and then add these 4 zeros. These 4 zeros, I can just add it to the back. 1, 2, 3, 4. Commas here, so it's 98,600,000. So that's what 9,680, 10,000 is. So we're going to do the same thing here. 60,000 thousands, so 60,000 thousands. Right? But it also says 400 hundreds. So we're 40, 100, hundreds. So we're going to write down 40, 100 hundreds. So 100, since hundreds is 2 zeros, and hundreds again. So that looks like it's 400,000. So we're going to find the 100,000th place in our digit and just put a 400 there. So that's our answer. 8, 10,000. So 8, 10, but that's 8, 10 thousands. But we're also adding 5,600 thousands. So what is that? Well, we have 5,600. Got 2 decimals, 2 zeros, thousands, 3 zeros. So these match up, right? Then it should be 56, 8. 0, 0, 0, 0. So we have 5,680,000 right now, but we also have 8 ones. So the last digit is just going to become an 8. So our actual answer is 5,680,008. That's just what it is. 8,001, so that's just 8,000. 12,000 tens. So that'll just be tens is 1 0, so just add a 1 there, so 12, 0, 0, 0. 120,000. And 4 millions is exactly what it looks like. 4 millions. So actually what I'm going to do is write 4 millions here. And then just replace it. So 120,000. 120,000 and 8,000 ones, which is 8,000, so it becomes an 8. And that's the answer. Same thing here. 50,000 10,000s. Well, what's that? 50,000. 10,000, so that's another 0, 0, 0, 0. Boom. 500 million. So we're going to write down 500 millions. 6,001, so this becomes a 6. 3,000 thousands. Well, that's just 3,000 thousands. That's just 3 million. So millions place becomes a 3. And then we have 4,010. So we'll just, add 40,000. So 406. So that's just 503,046,000. Moving on to exercise 2, basics. So this is just simple addition. Well, look at this here. We have 3. So each dot here says 100 on it, so it represents 100. And we have 3, so it's 3 times 100, which is 300. Alright, over here, oh, it's just 10, and we have 2, so it's 2 times 10 is 20. And we have, moving on over here, we have 1s, and we have 4 of them, so it's 4 times 1 equals 4. And this is the hundreds, tens, and ones, so we just add them all together, and we get 324. Now, if you look at this, it says, look at this for me, it says times 10, and it's just times 10, so we still have 3 of these bubbles, but now they say thousands. We still have 2 of these, but now they say tens. Now they have 4 of these, but they say 4, let's say 10 on it. So we have 3,240 here. So all we're gonna do is just write 3, 2, 4, but we're gonna add a 0 because we have a 0 here and we have no 1s. Easy way to figure this out is every time you multiply by 10, you just add a 0 to the end. So we see this when we're moving over here. So we go 3, 2, 4, 0 times 10, add a 0. Let's do that again. Take this number 3, 2, 4, 0, 0 times 10, add a 0. Alright, so now we move on over here. So 324, we can check this with, times 100. So 100 has 2 zeros. So all we're going to do here is 324, 3 zeros, cross this out because they're exactly the same. So we have 1,000 here. So what I want you to do now is look at this. And I know you guys already did it on your homework, but from what you just learned here, which is that you can just add another 0 for each 0 you see. So there's a 1 here, so we should write 324 because 324 times 1 is 324. And after this, we have 2 zeros here. So we're just going to add the rest of the zeros here. That's all we need to do. C times 100, add 2 zeros. C times 1,000, add 3 zeros. C times 10, add another 0. So what I want you to do right now is pause and come back here. It doesn't matter if you already did it, I just want you to try it again. Alright, so assuming that you're done with this already, this is our answer. And if you're ever wondering how we got there, well, times 1, everything times 1 is 1, times 1, times 1, times 1, times 1, times 1, times 1. So we just copy and paste this down. But then we still have zeros. So what we're going to do is count the number of zeros and just add it to the end of our number. Alright, but what if it's like our number and then times 10, times 10, times 10? Well, that's going to take a lot longer, isn't it? Well, yeah, unless you can just, simplify it a little bit. Like, for example, I don't know, 3 tens, which is just 1,000. So then we have 6,201 times 1,000, which is just, as we all know, 3 zeros, add 3 zeros. And so the same thing here, we have 2 tens, we just simplify this to a 20. So we just take 12. Same thing here, we could just take 210, simplify to 100, and then so just 80,620 times 100, so 80,620 times 100, and that's our answer. So moving on to the practice, 24500. I'm going to assume we all know how to do this already, so I'm going to skip ahead to when I have filled this out, and you can. Anybody wondering why did I leave these two empty? It's because they have the hundreds and thousands in front of the number. So we're gonna need to do multiplication, right? Like this, and then just do this, right? No, you do not need to do that actually. This expression right here is equivalent to 6,230 times 100. So we're gonna do the exact same thing, 6,230, add two zeros. And same thing here, it doesn't matter, it's just times a multiple of 10. So 6,004, add three zeros, because it's equivalent to 6,004 times 1,000. And I'm going to leave you to redo this section to see if you know how to do it now or if there's anything to improve on. Alright, so these are the answers for question number 5. The reason we have 1,000 here is because it's 85, cross out 85 like we learned before. 1,000 here, 1,000 here, get three zeros. And here, 430, 30, cross it out, two zeros, 100, 40, 40,000. And then same thing here, 7,210, 0, 1,000, 1,000, two zeros, 100, 100, cross off 100 from the back, so 600. Alright, so right here we have a word problem. There are 1,000 paper clips in a box. So there's a box, and there's 1,000 paper clips in here. And the boxes are packed in crates. So we have crates with 100 boxes of paper clips, right? So we have this into a box that can hold 100 small boxes, right? So how many paper clips are in 100 crates? And so we have 100 of these, right? So what are we gonna do? Well, the first thing we're gonna do is figure out how many crates do we have. We have 100 crates. So we have 100 crates. Now I'm going to do something called dimensional analysis, which is very helpful when you are trying to multiply a lot of things and divide a lot of things from one thing to another. And dimensional analysis, you start off with what you have, 100 crates in this case. Make sure to write down the label here because that is very important. So we're going to multiply by dimensional analysis. Either the numerator or the denominator has to be 1. Because you're multiplying by a fraction the entire time. So the whole number is a fraction, like to divide. So I'm going to write out a fraction here. And so we have 100 boxes of paper clips in each crate. So what does that mean? Well, 100 boxes of paper clips and one crate. So this would be one crate here, and that means 100 boxes needs to go here. Right, so then we need to find how many paper clips though, and none of these units are paper clips. Right, so what we're going to do is find out boxes of paper clips. Well, there are 1,000 paper clips in a box. So the reasonable thing to do would be 1,000 paper clips to one box as like a ratio, sort of. So when you do that, well, you'd be looking at, when you do this, you need to look at your labels. Right, so we're trying to get to a label of paper clips. That's what we're trying to get as our label. So we have a crate here and a crate here. They cancel out. We have boxes here and we have boxes here. These cancel out. So all we have left is paper clips. And that's exactly what we're trying to find. So the next thing we're going to do is take these hundreds. So 100 times and the hundreds on the numerator here. So just 100, that's because the whole number. And hundreds on the numerator here. So times 1,000. 1,000 on the numerator so times 1,000. And since each of these say 1, we're just going to put a 1 here. With 2 zeros, 2 zeros, and 3 zeros. So 2 plus 2 plus 3 is 7. So we have 7 zeros. That's our answer, 10 million. And don't forget labels since it's a word problem and it's asking for the number of paper clips. Another way to do this without dimensional analysis, even though it's basically the same thing, is take your 100 crates, multiply by 100 boxes, because we have 100 boxes in each crate, and we have 100 crates, times 1,000 because there's 1,000 paper clips in a box, and we have 100 boxes, so just this times this times this times this. Alright, so we have 10 times 10 times 10 times 10 times 10. That's going to take a really long time, right? Well, not really. We have a 1 here, 1 here. These are all 1s, right? So we just write a 1 here. And we multiply by 10 5 times, right? So 1, 2, 3, 4, 5. We have 5 zeros, and all we're going to do is just add these 5 zeros to the end of it. Same thing with here, all 1s. So 1, 2, 1, 2. So 2 plus 2 plus 1, that's just 5. So we're going to add 5 zeros here. And that's your answer. 40 times 10 times 100. This question is difficult, right? This isn't a 1, this is a 4. But it's times 1 and times 1. So what we're going to do, just write a 4 here. 1, 2, 3, 4, 2, 3, 4. 1 times 1 times 8. Well, we're going to do exactly the same thing, just write an 8 here. Well, we have 1, 2, 3, 4, 5, 6, 7. So we add 7 zeros after this. And that's the answer. And it looks like it's another one of these, except this time we have 324,000. And we're dividing by 10. Well, when we multiply by 10, all we do is add a 0, right? So in dividing, that just means we subtract a 0. Because dividing is the opposite of multiplying. So when we have divide by 10 here, we're just going to take away 0. 3, 2, 4, 0, 0. And we're dividing by 10 again, so we're just going to take away 0. Again, divide by 10, 3, 2, 4. We'll do exactly the same thing we did earlier in multiplying, except the 10 with dividing. We can take 324 and they're exactly the same. So we cross this out and we're left with 2 zeros. Divided by 100. Yeah, but 324 here, 324 here. We'll cross that out, 3 zeros. So that's just going to be 1,000. Just 3 zeros. So I'm going to let you guys do number 2 right here. Pause and redo it if you want to. Try to fix your mistakes if you think you had any. And then unpause when you are done. And welcome back. So what I did was I found zeros here, counted how many zeros I have here. I just took that away from here. That's all you need to do when multiplying and dividing by a multiple of 10. So here, look, we're getting to fractions here. So it looks like we're doing is taking this number, putting it up here, because this division is the same thing as a fraction. They're the same thing. So we have 56,000 over 100. And all we're going to do is take 2 zeros here, exactly the same, 560. 5,600,000, 5,600,000, divided by 1,000, found 1,000, found 1,000, 5,000, 5,600. And that's your answer for these two. You can do number 4 and 5. Pause and come back when you are done. And we'll come back. So there are 2 questions I want to touch on, and they are A and C for number 5. This is because you might get tripped up by these commas. This comma after the 85, but this comma's after the 8, so you might be thinking, wow, there should be 8500. This is wrong, because you need to count the number of zeros here. There's two here. So I wanted to touch on these 2 questions because of this. The comma might trip you up. You want to take out 3 zeros and 3 zeros here, not 2. Some people might take out 2, but you're actually left with 2 zeros, so it becomes 100. So this answer 100, and over here, so something times 1,000 equals 4,500. But there's 3 zeros here, and there's 2 zeros here, but it's divided. So what are we going to do here? We're going to take x equals 4,500, and all we're going to do is move this to this side. So times 1,000. So this becomes x, which is just our variable for now, equals 4,500. 3 zeros, add 3 zeros. And that's our answer for this one. We have 2 more word problems. So we have the supplier paid $71,000, so $71,000 for 1,000 portable photo printers. So we have 1,000 printers. How much did the supplier pay for each portable photo printer? Well, how do you find this unit cost of a printer? Well, take for example the unit cost, let's say equal x, which is our variable for now. So we're going to have 1,000 of our variable x, so 1,000x equals 71,000. And the reason we do this is because if this is the unit cost of the printer, which we know is what x stands for, we can declare it, and we get this declaration because we already know the number of printers we have. We're just finding how much you paid for each, which is x. So 1,000 times x, so times x equals 71,000. This real quick means time. It's a dot, not this. And we're going to do exactly the same thing we did over here. We're going to move 1,000 over, and so it becomes x equals 71 because we can cancel this. So that means the unit cost of a printer is $71. Another word problem for a box top for education program. Purchasing 1,000 participating products with box top logo and scanning the receipts is worth $100. So we know that 1,000 products is $100. If 630 students each uploaded 100, how much money would the school receive? So the first thing we're going to do here is figure out our variables, or if we need any. Variables are like x here. So 1,000 participating products is, so products can be x. Right? So we're gonna have 1,000 x. So how much? We're gonna have 1,000 x. So how much money would the school receive? Well, so if products is x and 1,000 x equals 100, and we have 630 students, so 630 each uploaded 100 box top scans, which means we're gonna put parentheses here, which means multiply 100x for 100 scans. So each student does 100 scans. So what we're going to do is how much money will the school receive? Cost. So price X is actually going to be price of the box top logo. So what we're going to do here is figure out what X is. So X equals 100 over 1,000. You could just move this over. When you cross out this, well, you get left with X equals 1 over 10. But 1 over 10, is it a unit of money? Not anything I've ever heard of, except compared to a dollar bill. Dollar bill is worth 100 pennies times 1 over 10 because it's a tenth of a dollar. So we figure out how much in coins this is, which is just 10. So each box top is 10 cents, which conveniently you find here. So did you do all this? Yes and no. It's better to practice doing it when you can, and it's a practice. But during a test, if you see one of these, maybe you see a hint about the price, so you don't need to do that. You can use that, though I recommend actually solving it just to make sure you know it's not just a random guess. So which one of the school received you would figure out 10 or 0.1 if we're looking at decimals. So we're going to put 0.1 in for x here. So 630 times 100 times 0.1 equals blank. So 0.1, so that's just 1 over 10, right, as we saw earlier. So we do 100 over 10, cancel that out, is 10. So 630 times 10 is 6,300. So when you say how much money will the school receive, well, they made $6,300, right? Well, yes. So is that right? Yes. And we can actually double check this. That means another way. So if we figured out each box top is 10 cents. Here, I cut this out. Alright, we're gonna move on to division, more division. And like we did with multiplication, we have 4 tens, which is just 10,000. And then move 4 here, so 10,000. Let's count 4 zeros left. The same thing here, there's just 3 zeros. Move this, 20,000. And I'm going to fast forward. Alright, so this is the answer for number 8. This is the answers because you count how many zeros you have and cross this out. Alright, now we're going to move on to multiplication. Now we see 31 times 5 ones, that's just 31 times 5, and we can do 31 times 5 is 155. So 31 times 5, 5 times here, and 5 times here. So it's 5 and 15, so 155 ones. And we know this because it's basically having one thing 155 times, which is just 155. So the answer is 155. 3 times 5 tens. 5 tens is 50, so it's 31 times 50. As we already know, 31 times 5, 5 is 155. So 155. There's 0 here, so 0 here. Is this an answer? No, because our units is tens. So our answer is actually just 155. Because tens already means times 10. So it's answer 155 times 10. 31 times 500 is 155. The reason being is because we know hundreds is here and hundreds is here. That's the same unit. So just 31 times 5 and then the hundreds after it. And then so we're doing this and do without units, basically, so it's just times 100. So 155, 0, 0. We do exactly the same thing here. You see thousands here, thousands here. 31 times 5 is 155. 155 is 3 times 1000. So we just add 300. 28 times 4. 28 times 4. 32, 8 here, 11, 112. Okay, so answer here is 112. So 28 times 40 is 28 times 4 times 10. Like I said earlier, so 1112. This is the same thing as saying 1112 tens, right? Because this means times tens. So we're saying this, it becomes 112. And then, as we all know, that add 0. 28 times 400 equals this. You can break it up into 4 and 100. So what we're going to do now is 28 times 4, as we already know, is 112. 112. 112 times 100 is the same thing as 112 hundreds. 112, 2 zeros, add 2 zeros. Break up 4,000, 4 and 1,000. 28 times 4, 112, 1,000. Pretty easy, right? 5 times 8, 40. Do exactly the same thing. So 5,000 times 8. What's 5,000 times 8? So 5,000 times 8 is the same thing as 8,000, and times 8 times 5,000. Right, so what we're going to do is exactly what we did earlier. We're going to take 5,000 and break that up into 5 times 1,000. So our answer is just 14, because 8 times 5, and add 3 zeros. 5,000 times 8,000. Well, you can break both of these up into 5 times 1,000 times 8 times 1,000. And that does look really complicated though, doesn't it? So over here, just wants to write 8 times 5,000, because you can rearrange these. But you can't split up 5,000 into 5 and 1,000. And this does look really complicated. 5 times 1,000 times 8 times 1,000. Like, what are you going to do? Well, as we know here, 5 times 8 is 40, so we can take out 5 and 8. 40. And we have 1,000 and 1,000 here, which is the same thing as 1 million, right? So we're taking 1 million times 40, and as we already know, 1 million is a multiple of 10, so 40, add 40 million. So practice here, I'm going to let you guys do this. Real quick, I'm going to have an example here. So 35 times 20 is exactly the same thing as 35. We're writing some blue times 2 times 10, which is the same thing as 35 times 2, which is 70. By the way, 35 times 2 is 70. And adding another 0, so 700 is here. Alright, now I want you to do B to B through H and come back when you are done. And welcome back. These are all the answers under this. I'll give you some time to look it over. Look over it and then move on. Moving on is going to be exactly the same way. And this is the answer for number 5. All these are the answers. I basically just did exactly the same thing and put everything back together, and that's your answers. Now moving on to the word problem. New Zealand had a population of about 4 million people, so that's 4 million people, which is relatively small. There are about 20 times as many sheep in New Zealand as people. So how many sheep are in New Zealand? This is really easy. 4 million times 20. That's all you need to do. 8, 3, 4, 5, 6, 7. And that's your answer. 80 million sheep. These are basically dividing again. So 85 tenths divided by 5. So there's 85 divided by 5. 1, 5, 3, 5, 7, 17 tenths. Or 170. Alright, so I'm going to do this really quickly. And then we're going to do this. So this looks really complicated, and you think you might need a calculator or something, but you don't. Because as you see right here, you can just split up 8,000. If you want, you can split up 40,000 into 40 times 1,000 too. And then you can just take 1,000, 1,000, 40 divided by 8, because we all know it's 5. Same thing here, split up 800. Although you don't really need to, you can just do this, and this will become 400 divided by 8, which is 50. And now right here is exactly the same thing. You can just do this. So it's 4,000 divided by 8, which is 500. And they show you this right here. So 560, and then 560 divided by 7 is 80. Yeah, this really big number times 7,000, but as we all know, just write this down. That's all you do. Write this number above this, because this is the same thing as a fraction. And just cancel out 3 zeros. It's 5,600. And then after this, we know it's 800, since 56 divided by 7 is 8. Same thing here, 80,000, cross out, 800, 800 divided by 5. Well, what is that? So, just write it out. If you don't know, 5, 30, so 6, 160. So yes, 160, and then 960,000 divided by 80. Cross this out, so 96000. Then we all know 96 is just like, you know, 12 times 8, 96, yeah. So this is just 12,000. And here's the practice. You guys can do this on your own. Don't wait, it's recording.
Oh, it's still recording.
Because it's 18 pages.
No, it's not.
Is it?
It's still in 18 pages. When are you done?
I'm almost done. I don't want to record. So this is the answer for number 4 and 5. Moving on, we have, not surprisingly, another word problem. A grocer paid $4,500. Always find it helpful to list out what I know on the side as I'm reading this question. So 300 bushels. And how much did each bushel of apples cost? So just 300, and x for the cost equals 4500. So x equals 4500 over 300. Cross this out equals 15. So each one, bro, cost of $15. Digit 7 is in the 10 millions. This is check what you know, so I'm gonna let you guys do this, and I'm going to do this really fast. And this is the answer for the check. Check if you have the same answers. You do good job. If you don't, go back and figure out why you got wrong. Or by chance, I got wrong. Number 2, write greater than or equal to SI greater than or equal to in each circle thing. I will write down the answer again, because by now you should know how to do it. And I'll be back to you when I'm done with this. And now we're moving on. This is the answer, by the way. And now we're moving on to question number 3. Once again, just do all parts. As a matter of fact, do the rest of this page, and I will catch up with you when I'm done. And this is my answers for this review. I'm going to explain number 4 because it seems a little bit difficult, maybe for some people. So basically, if you're using each digit from 0 to 8 only once without any restrictions, then obviously the smallest number without any restrictions, then obviously the smallest answer is all zeros and the largest answer is all 8. But we do have restrictions. We can only use this once. So that means the smallest number we can have is 0, 1, 2, 3, 4, 5, 6, 7, 8. And it's a 9-digit number, 12,345,678. But since the restriction was 7 in the tens thousands place, so 10,000th place must be a 7. Right, so then maybe we should replace this with a 4 then, right? Well, no. Because if this was a 4, and I move everything back, then this will be about 1,000 um, less than our previous number, which is smaller. So this would be our answer. And that is all there is for chapter 1.